myself a nice little farm trailer, and I'm looking at some steel properties, and I'm looking at some channel. I'm going to buy some C channel, maybe a C6. By the way, when I say C6, what is this dimension? 6. Yeah, that's what it's all about. The width value, that may change a little bit based on the overall weight of the beam, whatever it's sized for, and you can look that up. But let's say I'm looking at the plans. I get them offline. How about that? We get it offline. I go to one of the do-it-yourself websites. I get these plans, and it says I need to go to my nearest steel place, buy some C6 channel, and I need to make sure that I get A500. Well, I go to the place, and they say, well, we got some C6, but we've only got an A36. Should I take it, or should I not? And why?
Well, 500 is stronger, so.
So you're saying I should go with I should not take it or take it?
He has the 36. If you need 500, that means it's probably not strong enough.
That's right. That's absolutely true. These numbers, even though we have a tendency to skim them on a set of plans, numbers like this matter. Now, oftentimes, numbers like this fall into the category called specifications, but I can go buy a C6 channel, and it could be this shape, but it could be this value or this value. Now, who knows what actually these 500s and 36 mean?
Is it KPI?
KSI. So the 36 factor and the 500 factor, although it's technically just the 50, means that this steel is rated for 36,000 pounds per square inch. That's what the K is. Technically it's PSI, but it's 1,000 PSI, so they changed the P to a K. So when I say 36 KSI steel, what I mean is 36,000 PSI steel. Now, what that essentially means is that its particular strength value rates in the 36,000 pounds per square inch capacity. But if I go by the A500, what's that value? 50. Now, most of your 50,000 PSI. Or 50 KSI. Now, most of your building steel projects, they're going to call for A500, 50,000, like your W beams and those kind of things. Whether a person needs 500 or not, that depends on the designer. But if it actually has it on the plans which type to get, you have to watch for that kind of thing because there is a major difference. Now, by the way, what does HSS stand for? Well, we got the term, that is the common, there is a different interpretation sometimes with this. It actually can have two meanings and abbreviations on a set of plans.
Such as hollow structural.
You can have hollow structural, however you will find some folks, you will see some call outs that they'll call it HSS or HSS for what they consider high strength steel, which would be their equivalent of saying A500. Okay? However, on the terminology factor, the HSS typically means hollow structural steel. That's basically, it's actually more of a shape word than is a strength word, but we have seen this interused quite a bit, enough on a set of plans that you just need to be aware that it might be two different, totally different interpretations, okay, for the HSS. So if they're talking about strength, they actually mean A500. If they're talking about actual shape, they're talking about HSS. However, on most set of plans, you won't see it used for reference to the shape because it's kind of understood that if I go buy a 4x4 by quarter tube, I'm getting a hollow structural steel tube. Okay, that makes sense. So just be aware the HSS has some different connotations in the trade. Yep.
And is another reason for that they don't consider it high strength until it is 50?
Yes, that is absolutely correct. Is that the high strength? This is what everybody started off back in the day. You had your A36, 36,000 pound steel. That's actually what most of the original calculations were based off of when we started doing this kind of stuff way back when. Then someone comes along and says, well, we need a higher strength to get more structural value out of it. So they switched to this one. But then people started using the HSS term associated with high strength steel instead of saying A500. Does that make sense? So just be aware there could be some trade differential with that abbreviation HSS. One of the key things that can't be changed, though, is what this means and what this means, and it matters very much so on a set of plans. Whether you're doing fabrication and manufacturing, you're doing fabrication for large steel buildings, both conditions apply, and it does matter. Now, let me ask you this. Let's say I am building my little farm utility trailer. Which is more likely that they're going to call out in their plans, A36 or A500? A36. It's more typical. Chances are I'm not going to load this trailer down with so much weight that I'm going to be needing A500. Typically it's more about deflection than anything else, which these values don't affect or significantly. So you're looking at A36 as sort of your common grade steel. This is the stuff that people are ordering for when lives matter, this is the stuff they're ordering. Okay? Aluminum and all your other materials, they all have the same thing. They all have different grades, and they're typically established by this group right here. And no matter if you're in manufacturing or fabrication, whatever the case may be, this group matters to you. Who are they? Ever seen this name before? You've probably seen it. It's actually probably been on like every American Society, testing, and what's the M stand for? I need a commitment here.
I know.
Go to their website. You can always go to their website and find out what the M stands for. I'll leave that up to you. But essentially this group, ASTM, stands for the group that makes all of our standards in terms of materials. All right? So when it says an A36, it's actually referring to ASTM standard of an A36. And we have this in additive manufacturing, we have this in steel, we have this in plastics. This group is the body that gives us a standard so that when you're in one area of the country and you've got 3 or 4 or 5 or 6 different subcontractors to order parts from, if each one of these people say that their product meets ASTM such and such value, then you can trust that no matter who you select out of this group, you're going to get the same level of quality. Now, ASTM just doesn't deal with materials, they also deal with processes. There's actually standards for how you process things, how you actually do certain types of, like powder coating, for example, or a welding process can actually be established by the ASTM on how to do it correctly. So it matters when it comes time for a person. Let's say this person's going to be producing, $10 million worth of product on contract, and they have to order from these subcontractors, and they have to make sure that they're going to get the highest quality they can get because they've got to produce stuff for the Defense Department. They need to know that each one of these groups is doing ASTM standard stuff. If we didn't have standards, what would happen? You never know. I mean, this guy could be giving you a great price and be using crap material. Safety, absolutely. You can't do business in the commercial realm without having standards that people will say, my product meets this standard. And if you actually look at your normal stuff that you buy, your vehicles and everything else, there is standards going into the actual production of it. If we don't have standards, then we can't really do business. So that's a big deal. Yep.
Yeah, it's American Society for Testing and Materials.
Materials it is. Now, it often gets confused with manufacturing. Although manufacturing is very highly tied into ASTM, it's all about the materials, but they basically have standards for just about everything. So the ASTM is a group that you will see associated somehow with your work no matter what you do. They're involved, or their standards are involved. Fireproofing, I mean, even the drywall on our buildings is associated with ASTM standards. Yep.
Another good point on what you're saying, because of the standards like that, that allows insurance companies to be able to cover your operation.
That's absolutely true. So if I build building here, building A, and insurer B wants to actually insure this building, and I can tell them, hey, I used ASTM standards for this, 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 and this, then guess what happens to my insurance price? It goes down, and can go down significantly. So it really does. It matters in terms of insurance, liability. Let's say something does go wrong. Let's say that somebody drives their pickup truck, here they go, right into this building. That's a horrible pickup truck. There, long bed. There we are. Runs right into it. And I've had to deal with one of those. I had a house damaged because a car ran off the road and ran into the side of it. But anyway, let's say it runs into it and this building collapses. And we get, a pile of rubbish. Nobody was there though, so nobody died. But there is a lawsuit. And the court system starts looking. Here's the justice system. Here's our little, there we go, our scales. There we go. Our justice system looks at our product, and I get to say, yes, I followed all my material met ASTM standards. I followed all standardized procedures. I did everything by the building code. What does that do for me in court? Exactly. We basically have the law is on our side in this scenario. So that's what you got to be thinking about in terms of blueprints. Now, if you skim a set of plans and you miss a standard, that can actually have big impact on you. It really, really can. So even though specifications and things like this are very boring, they're not visual, they're just reading stuff, it can come back to bite you if you're not careful. So watch out for them. Those notes are there for a reason. Now, let me ask you this. Let's say that you're a fabrication, or you're just doing a project for somebody. You're doing a little subcontract work, and they have this design they send you, and it's a widget. It's some kind of new thing. It's widget A. And they say, here's the dimensions, and they write a few notes about paint it black, make it out of this material, but they don't require you to produce standards. Do you have to actually go out and buy ASTM 5 blah, 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 or not? Not really. Could you choose to do so? Yes, it might even justify a higher price. You could even say, well, your other competitor bids only gave you this material, but I'm using ASTM standards, blah, 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 and you can justify higher prices associated with it. Yep.
And what you're saying, of course, is correct with the information, but like you said, what you should want to do is be very careful, because remember, especially if you're a licensed manufacturer, whatever, liability, your butt's going to be going on.
That's true. Especially if this ends up in the product. You have to be concerned about your license and your liability associated with what you produce. So all important questions, and it's not legal jargon that you can't understand. It's stuff that it's the basic stuff that you can learn and train yourself on to help you get started if you want to go into a business like that. So anyway, backing all of that up, that was our first question associated with the stuff. Let's talk about other things. Let's talk about some threads. So tell me a little bit about threads. They can be external, or they can be what? Internal. They can be metric. They can be our typical, English system that we like to use. Can the call-outs of a set of threads look different if they are metric versus English? They absolutely can. What is a way that I totally identify that a metric bolt is a metric bolt? By a call-out. What's it going to have on it? It's the very first thing, huh? It's going to have an M right here, right? Then, what's it going to have? All right, a 10, but what does that represent, for example? Do what? Millimeters, but physically.
Diameter.
Which kind of diameter, though? There's two different types in terms of a bolt. Keep in mind, a bolt, right, but it has a better term than that. It is the outer. What is that term, though? Now, it has an M in it as well. Actually, both of them do. You got your major and your minor. Okay? Major and minor diameters. Which, does that really matter to you a whole lot? Not really. But just for terminology's sake, when you get that 10, that is diameter. That's the general diameter that we're considering, but technically that's the major diameter. All right? So, with that in mind, then we have a little X or a bi symbol here, and then we have what value? What comes next? The pitch. Now, what is the pitch in concept? And keep in mind, the terminology is a little bit different between metric versus English. So a metric pitch is what? Well, that's the units. But what in concept?
The number of threads per.
That's English. Pitch is a little bit different in metric system. When in doubt, Google it out. You can coin that phrase. Metric thread pitch. Do an image search, and look what it says right here. See it on the screen? The isometric thread profile, your pitch is the distance from what to what? Thread to thread. So, whereas you're used to the English in threads per inch, that's not the same as our case with metric. Metric is thread to thread, and therefore it's going to be a much smaller value, right? So think about it. If we were calling out an English version of something, and this thing says 1.5, that doesn't seem right in English, right? You can't have 1.5 threads per inch, but in metric you can have 1.5 distance from thread to thread. Okay, see the difference? Now, does it necessarily matter to you that much? Probably not, because everything's so standardized that the M10 is going to be the M10. So you can often see people just skip the whole pitch part and just do this. Let's go 25. What does that mean? It's not the pitch. They could erroneously actually put an X in by there. But what would be the next value after pitch, perhaps? Generically speaking. Well, if you're going to order a bolt, what do you need to know? How long it is. Right. Now, by the way, just so, since we think about the English system, how long is this bolt in English? If this is an M10, so all right, we got a 10 millimeter diameter, and it's 25 millimeters long. How long is it in English?
Just a little under an inch.
Just a hair under an inch. Remember, 25.4 is your conversion factor from millimeters to inches, or there's actually 25.4 millimeters per inch. And if you just remember 25, you'll be in good shape. Okay? For every inch, there's about 25 millimeters. So that kind of conversion is a big deal to you, because you have to jump back and forth a lot in different forms of manufacturing. Mechanical, structural, everybody deals with different stuff. So that's a thread callout. Now, let's switch over to an English callout real quick. Let's look at one real fast. English thread callout. And when in doubt, whenever you need to know stuff, you can always find some cool things. Check it out. The American Unified Thread System down at the bottom gives you a great little way to list this out. Now, in this case, when I actually did this, I mean, I'm giving you something realistically. Technically, they're not going to go dash this long. They're going to go class fit and class, you know, all that good stuff. But you will see sets of plans where people will call out a bolt size and just say M10 and then the length, okay? So anyway, going to the American, basically American Unified Thread System, you got a 3/4-10-UNC. What's the 10 stand for? In the American system?
10.
The 10?
You mean that's where they have
Threads per inch, right. The 10 right here.
Oh, that, yeah.
Yeah, so that is, threads per inch. Whereas here, notice the difference. You know, just keep in mind, it says thread pitch, threads per inch. Make sure you understand the difference between the two. They are not the same.
Oh, so they're not saying that the threads per inch is there as pitch. They're not. You know,
Right. That's exactly right.
Yeah.
So here's what you're getting a call out for. So to draw this for you, this is the pitch for the metric system, this distance right here. Threads per inch is, bing. I mean, it is sort of a pitch concept, but it's like, here's 1 inch. How many threads can you count from here to here? The TPI. Okay? Notice the differences between the two.
And
Metric is more simple, which is what we find a lot of times. It is a simpler system.
And like you're saying, technically speaking, you could do it either way, but when you go to measuring the distance from your threads, you could get 10 threads in an inch, but you can also make a difference in how far each one is apart.
Absolutely.
And still have 10 per inch.
Absolutely. There's a lot of ways that you can get this particular component confused. And visually, if you just see the visual right there, that'll probably help. Metric, we're going from hilltop to hilltop. English or American, we're figuring out how many hilltops we can fit in an inch. That's the best way to kind of think about it. Now, your thread series, the different types of series, that usually comes in afterwards. However, on a lot of thread callouts, a lot of times they will omit this. And if they omit this information, what will you typically assume? You're going to assume it's a UNC. Okay? What does the F stand for? It basically means it goes from coarse threading to fine threading. Basically, will that increase your number of threads per inch? Yes, it will. Because it means we got tiny little hilltops, which means we can fit lots more in that 1 inch. And then, of course, class of fit, you probably won't see this on a call-out most of the time. And then we've got external versus internal. And then if they don't show anything out here, what direction do we assume it is? What rotation? Right hand. Unless they have an LH or left-hand note, you assume it's a right-hander. So, but reality is a lot of times you will just get this information on a call-out. It's assumed that this is understood unless it's specific, and in some cases you may just get a 3/4 inch by 10 bolt is what they may say on a call-out, which is enough information. Yep.
When they're having the UNC versus for the is that US? Or?
UNF. It's either UNC or UNF.
Okay, so the N is not representing a word. It's just.
It's unified. And really, they could just say C or F, honestly, because it either means coarse or fine. So technically, either one of these, they really don't need this in all honesty, but that's why they put them down. That's the standard. I think ANSI does this, or the ISOs. I think ANSI also has some standards too, but most of the time the information is about the same. Questions on this so far? Thread callouts are important. You got to order the right parts to make your stuff go together. And especially when you consider that you might happen to be doing a good old-fashioned bore and tap, which means what?
Tap.
Yeah, when you're going to bore and tap something, what are you going to do? What's the reality of what you're going to do? You're going to basically drill a hole, and you're going to take a threader, and you're going to stick it down in it, and you're going to create threads to create internal threads to receive an external threaded thing. Now, don't get me wrong, we can do this without bolts. You can buy threaded rods. You can thread things yourself. There's all kinds of ways that threads can be used that aren't actually just bolts or screws. So keep that in mind. Any questions you want to ask? All right. That's a good stopping point there.